Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. In today's class, in our class, we are going to discuss non-conventional sources of energy. So as part of our class work, today's class, we are going to discuss direct energy conversions. Okay, so let us start today's class. If you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, so now we will start today's class. So this is direct energy conversions. So first we'll come to know what is direct energy conversions. So here in this direct energy conversions, a energy is directly converted into electrical energy from a source. Okay, so here first we'll start with the meaning of this direct energy conversions. In direct energy conversion system, the energy from the source is directly converted into electrical energy without the interposition of working substances that undergoes a cycle. Okay, so here simply we can understand from it is a conversion is taking place, okay, from a source in which it is directly converted into electrical energy. So direct energy conversions, so here commonly we use three types. Here you can see the common devices employed in direct energy conversions are, see here, photovoltaic cells, fuel cells, magnetic hydrodynamic MHD generator. Okay, you can see magnetic hydrodynamic generators, and this is the fuel cells. Okay, right, now we'll start with the fuel cells. This is as per our syllabus. We will discuss this fuel cells. Fuel cell is a device which converts chemical energy into electrical energy. Okay, fuel cell is a device which converts chemical energy into electrical energy. So in this case, you can see fuel and oxidizer here. Oxidizer are combined chemically to produce electrical work. Okay, so we are having one diagram. With the diagram we will come to know how this fuel cell will work. Okay, so here you can see this is achieved by two reactions that occur on separate electrodes, that is the fuel and oxidizer do not come directly into contact with each other. Okay, so here, so about we will start some introduction of this fuel cell. The first fuel cell was developed by Francis T. Bacon and J.C. Frost in 1959. According to Bacon, fuel cell which uses potassium hydroxide solution electrolyte, hydrogen as a fuel and oxygen as oxidizer. So we will be using this hydrogen as a fuel and oxygen as the oxidizer in this figure. So we will see this figure. So this is the diagram of your fuel cell. So if you are definitely will get a question regarding this fuel cell, so you have to draw this diagram and explain what is exactly happening inside this fuel cell. Okay, so we know it is a conversion is taking place in this fuel cell. So what is the conversion here? See, chemical energy is converted into electrical energy. Okay, so in this fuel cell, what is happening in this fuel cell is chemical energy is converted into electrical energy. Now we will learn how it is happening. See here, it consists of anode, a cathode and an electrolyte. Okay, now we will see. See, this is the anode in this diagram. This is the anode. Okay, this is the electrolyte and this is the cathode. Okay, so you can see here anode, electrolyte and cathode. Okay, next what is happening? Anode and cathode are made porous carbon or nickel electrodes and potassium hydroxide solution is used as electrolyte. Okay, so see here anode and cathode are made porous carbon or nickel electrodes and potassium hydroxide solution is used as electrolyte. So here you can see in this electrolyte what is happening. Potassium hydroxide solution is used in this electrolyte. Okay, so in this electrolyte. Okay, so you can see, so as I told you, this is the anode, electrolyte, cathode. So here fuel is entering and here you can see the oxidizer is entering, and here after conversion is taking place, what is happening? Product water is leaving outside. Okay, now we will see how this conversion is taking place, and on top of this diagram you can see external electric circuit. Okay, here you can see external electric circuit. Okay, now we will discuss, see here, anode, the passage. Now we will see exactly what is happening inside. The passages are provided for flow of hydrogen fuel and oxygen oxidizer into the fuel cell, and for the flow of reaction product water from the cell. So you can see here hydrogen is fed into the anode inside of the cell. Okay, so hydrogen is fed into the anode side of the cell, and what is happening on the anode surface? Hydrogen combines with negative OH from electrolyte to produce electrons and water. So here see, this is the exact conversion taking place in this diagram. Okay, so here solution is filled in this electrolyte, right. Now next we will see here the electron enter the external circuit and water goes into the electrolyte. Okay, now see, where is the external circuit? See, you can see external electric circuit. What is happening here? Electron enter the external circuit and water goes into the electrolyte. Okay, so the anode reaction is represented as 2H2, that gives 4H, right? So next we will get 4H plus 4OH, that is equal to 4H2O plus 4E, right? Next, this is about anode. Now we have discussed about this anode. Now we will discuss about this cathode. Okay, see here oxygen is fed on the cathode side. So you can see in this diagram, this oxygen is fed on which side? Oxygen is fed on this cathode side, right? Hydrogen is fed on, you can see this diagram, hydrogen is fed on this anode side. Like that you have to remember. Solution is filled with in the electrolyte. Okay, next what is happening here? On the cathode surface, oxygen combines with water from the electrolyte and electrolyte from the external circuit to produce negative OH ions and water. Okay, now the OH ions are carried away through electrolyte and the water is discharged from the cell. Okay, so water is discharged from the cell. See, you can see the product coming outside. So direction is very important, right? So this is the outlet direction in which water is coming from the cell. Okay, so here you can see what is happening here. So in this cell, electrodes separate the ionized fuel and oxidizer from the electrolyte. So the cathode reaction is represented as O2 gives 2O and 2O plus 2H2O, that is out of 4H2O produced at anode plus 4E is equal to 4OH, right? So last, a single unit cell, you can see a single unit cell can produce 1.23 volts. By combination, it is possible to produce more power. Okay, to produce more power, the smaller unit needs less maintenance, but initial cost of cell is high. Okay, so we can see the conclusion. A single unit cell can produce 1.23 watts. Okay, 1.23 watts of power. Okay, so this is about our fuel cell. I think all of you understood today's class. If you are having any doubts, please post in the comments box. I will give you reply. Okay, so if you are having if you need any additional information, please post in the comments box. I will give you reply. Thank you very much. Thank you for watching.